For this lesson, we're going to be looking into some more details with similar triangles. So you have your note sheet in front of you. So if you look at example number 1, you have a bigger triangle that's labeled ABC, and then you have this smaller triangle, A prime, B prime, C prime. Okay, so we know based on how they're labeled, the bigger one was the original triangle, and it has been scaled down, and the new triangle is the smaller one. So if we look at the question, it says, based on the information given, is ABC similar to A prime, B prime, C prime? And explain. So what we've been talking about lately is to know if they are similar or not. First of all, if they have the same scale factor applied to all sides, they're going to be similar. Or if they follow the angle criteria, then they will be similar, because that means the third angles in each triangle will also be congruent. So based on the information that we have here, we really don't have enough information. If you look, there's only one set of sides that we can determine the scale factor from, and that's side BC and B prime, C prime. So I know if I were to find the scale factor, prime divided by the original, you'd get 2/8, which is 1/4. But in order to be similar, the other sides would have to have that same scale factor applied to them. And we don't know that for sure, because we don't know the length of A prime, C prime, and over here we don't know the length of AB. So we really can't tell if they are similar for sure or not. So moving on to part B. Okay, part B says, let's assume that the line containing BC and then line B prime, C prime, let's assume those are parallel. Now with that information, can you say that the two triangles are similar? So here's what we have. Since those lines are parallel, according to the fundamental theorem of similarity that we talked about, since those are parallel, that makes the corresponding angles congruent. That means that this angle right here at C prime would be congruent to C up here. That means B prime would be congruent to this B over here. And then they share the point A, so you know that's going to be congruent. So by the angle criteria that we've been talking about, that makes these triangles similar. So then using that, moving on to part C, we're actually going to start finding the lengths of the missing sides. So part C, we know that they're similar, so we want to figure out the length of side AC prime, which is this short length right here. So in order to do that, we had to first figure out what the scale factor was. And we already kind of talked about that a little bit. So I took the new length, B prime, C prime, and I divided that by the original, BC. So B prime, C prime was 2, BC was 8. 2/8 reduces to 1/4. So your scale factor is 1/4. So I'm going to use that, actually on this question and on the next question, to figure out the lengths. So for this part C, we're trying to find AC prime right here. So I take the original length, which was 6, and I'm going to multiply that by the scale factor, 1/4. And you end up getting, when you go straight across, 6/4, which simplifies down to 3/2, or 1.5. So the length of AC prime would be 1.5, or 1.5. Then on part D, we're actually going to look and try to figure out the length of AB. And that is an original length. So it's going to be a little backwards from what we've been used to doing. A couple of ways to do this. One way is you could set up a proportion and then cross multiply. So here's what I've done. I took 2.7, which is the length of AB prime right here, and I put that over x, and that would represent the length of AB, what we're trying to figure out. The reason I paired those two together is because they're both corresponding sides, AB prime and AB. And then I'm going to set that equal to my scale factor, which was 1/4, or I pulled that from these two sides right here, the parallel sides. So once I do that, then I can cross multiply, just multiply diagonally. So x times 1 is just x. And then I'm going to multiply 2.7 times 4, and you end up getting 10.8. So the length of AB, which is what we were trying to figure out, this entire length right here, would be 10.8. Now, we're going to flip over to the back side and look at a new set of triangles. If you need to pause the video at any time to kind of catch up with our answers, feel free to do that. But we're going to go ahead and jump over to the back and look at number 2. So they give us these two triangles. ABC right here is the smaller one. A prime, B prime, C prime is the larger one. And if we look at part A, based on the information that's given, are those two triangles similar? So, a couple of ways. Do we have enough side lengths to figure out the scale factor for all three? And we don't, because here we're missing BC, and over here we're missing A prime, C prime. So we could figure it out for one side, the scale factor, but knowing if they're similar or not, we need to know if it's the same for all three sides. The other thing we can look at are the angles. So do we know for sure that there are two angles that are congruent to each other, and that would fit the angle criteria that we've talked about? So I noticed that on each triangle they give me two angles. Over here they give me angles A and B, and over here they give me A prime and B prime, which I know those are corresponding angles. As long as they are equal to the correct one, then it'll fit the angle criteria. So here, angle A is 59 degrees, A prime is 59 degrees, so those check out. Over here, B is 92 degrees, and up here, B prime is 92 degrees. So since they have two angles that are corresponding with each other and that are congruent, then that means ABC is similar to A prime, B prime, C prime. Okay, looking at part B, now that we know those triangles are similar, now we're going to determine the length of A prime, C prime, which is this long side right here. So before we can know that, we need to figure out our scale factor. Okay, so the only side where I know the length on both triangles would be length AB and A prime, B prime. So remember, to find the scale factor, we always take prime and divide it by the scale, or divide it by the original. So in this case, I'm going to take 5.12 and I'm going to divide it by 3.2, which is what I've done right here. You end up getting 1.6. So your scale factor for this problem is 1.6. So then, to find the length of A prime, C prime, we'll just take the original length, right here, AC, was 6.1, and I'm going to multiply that by the scale factor 1.6, and you end up getting 9.76. So that would be the length of A prime, C prime. And then finally, we're going to look at part C. And here, again, we're going a little bit backwards because we are wanting to know the length of BC this time, which was an original length. So on this one, I'll show you the other way you can do this. The last time we did something like this, we set up a proportion and cross multiplied. That was over on part D on the front side of your paper. So essentially what we were doing is we just divided. We take the prime length that you know and you're going to divide it by the scale factor. That's going to give us the original length that BC started out at. So to find BC, we took the prime, which was right here, 8.96, and dividing it by the scale factor, which we just found on part B, that was 1.6. When you divide those two, you get 5.6. So that is the length of BC.